answer your questions. Regarding your attendance, that is already recorded. I think you all must have seen some of the faculties using this. Okay, so this automatically takes the record as and when you join the Google Classroom. So don't worry about your attendance. Savita had asked for solving that numerical. I'll just do that particular part, and if you all want me to solve all the different types in detail again, just let me know. Okay. So the first question basically is the image is given as 0, 2, 2, 2, 3, 3, 4, 4, 5, 5, 4, 4, 1, 1, 6, 7. Okay, so that's the image is given, and you're asked to apply the first one as neighborhood averaging. And second as median filtering with a 3x3 window. Okay, now let's say you are given this particular question and you're asked for 2 marks and sorry, a total of 4 marks. So that's 2 marks for this and 2 marks for this. Okay. Now, because it is 2 marks, you cannot spend more than about 5 minutes on this particular question. So it is suggested that you actually just write the output. So whatever is the output for A, whatever is the 4x4 matrix, you just put the answers in this, and then that is it for 2 marks. Okay. Now, see, exactly to solve this, if you can do this mentally, great. If you are having difficulties at the beginning, it will be very difficult to completely do this mentally in terms of at least neighborhood averaging. Okay, so how exactly do we go about neighborhood averaging? I'll just write over here, just refer to this numerical neighborhood averaging. So at 0, 0, okay, the value that it's supposed to come. Now, whenever you get any kind of convolution operation, so in your image, in your numerical, you're given this as the image. Sorry. This is actually your image, this entire thing, this 4x4. Okay. And the convolution kernel for neighborhood averaging is basically this. So I have 1/4 over here, 1/4 here, 1/4 here, 1/4 here, and the rest are zeros. So whenever you get any kind of convolution operation with an image and the convolution kernel, the way you proceed is you basically place this convolution kernel onto the image where whose value you want to calculate. Now, in this first instance, we want to calculate the value of 0, 0. So this particular central pixel in this convolution kernel, we place this particular 0 onto this image over here at 0, 0. Okay, so what we'll get is something like this. So we'll be having those values as 0, 2, 3, 3. These are my topmost, these 4 values. Okay, the neighbors of this 0, 0, it will be this part. Fine, this is clear. Then what I do is I place this convolution kernel with 0 as the center onto this particular pixel. Okay, so when I do that, I will be getting the values 0 from the convolution kernel. I'll use a different color so you all can tell. Black is the original image and this red is the convolution kernel values. Okay, so what I will get is 0 overlapping with 0, 1/4 overlapping with 2, 1/4 overlapping with 3, and 0 overlapping with 0. So this 0 of the convolution kernel here is actually this 0. This 1/4 here is actually this 1/4. This 1/4 here, this 1/4 here is actually this 1/4 here. And this 0 that I've written here is this one. So in this particular case, since this is actually the corner pixel, when I try to place this convolution kernel over here, my other convolution kernel values, it's actually going to come something like this. So my convolution kernel in red will be having, okay, that is not the proper thing size, something like this it will come, wherein I have the values this way, this. So 0, this would be 1/4 here, this would be 0, 0, 1/4 and 0. Okay, now since 0, 0 pixel is over here and these are going outside the image, okay, that is the reason why we don't consider those pixels in the convolution kernel. Now if you remember, in convolution, whenever we are solving the numerical that we were calculating, only the overlaps that were there, we were considering those values, the products of those overlaps. The rest of the values, we were just equating it to 0. Right? So that is what is happening over here. These values, these 5 values are directly considered as 0, and we are just calculating the products of these overlaps. So I get 0 into 0, 3 into 0, 2 into 1/4, and 3 into 1/4. So I can write this as 2 into 1/4 plus 3 into 1/4. And since the rest are 0, I can just write it as plus 0. And then I can just, in short, I can write this as 1 divided by 4 into 2 plus 3. So if you had seen me write the short form of a particular smoothing operation, especially for neighborhood averaging, I would directly write it something like this. That is because it is basically just I'm taking the 1/4 common out of this, and since the rest of the values, when I calculate the convolution, the rest of the values will be 0, I only take the 4 neighbors of those pixels, sum it up, and then divide that sum by 4. Okay, so that is the reason why when I do this calculation, you'll find me a lot of times doing 1/4 divided by the sum of the 4 neighbors of any of the pixels. Okay. Okay, so the answer of this will come as 2 plus 3, that comes to 5. 5 divided by 4, that will come to about 5 point, sorry, not 5.2, 1.2. So this rounding to 1. Okay, so this, sorry, so this pixel over here, 0, 0 will have the value 1. So the same way for 0, 1, I'll have to calculate the values. So this is going to change. I'll just rub this off just a minute. So now at 0, 1, my pixels are this. So this becomes the central pixel, and the neighbors are this 0, this 2 here, and this 3 here. So I can directly write as a shortcut as 2 divided, 1/4 into 0 plus 2 plus 3. So this result will again come to 5 divided by 4, which will again come as 1. So I write here as 1. Then I go to the next pixel, that is here. So the neighbors, the four neighbors will be 2, 4, 2, and since this is going out of bounds of the image, I don't have that particular pixel. So I take the sum 2 plus 4, which is 6, plus 2, which is 8. 8 divided by 4, that is 2. So I write this part, this pixel value as 2. Then this particular pixel, since I have only two of these neighbors, 2 and 4, I just have to take the sum of this 2 and 4 divided by 4, that is 6 divided by 4, which will come to about 1.2 again. No, sorry, 6 divided by 4, 1.5 it will come to. So rounding it up, it will come as. Then similarly here at pixel 1 comma 0, which will be the neighbors are going to be 0, 3 and 5. Sum is 8 divided by 2, 8 divided by 4, which is then 2. Then 1 comma 1 neighbors, the four neighbors will be 2, 3, 4 and 5. That comes to 9 and 5, that's 14 divided by 4, so that's 3.5. So rounding it up to 4. Then the next pixel, neighbors will be 2 plus 3 5 plus 4 9 plus 3 13. That's 3.2, so round it to 3. Then here neighbors are this 4 and this 2. That's 10 divided by 4, that's 2.5, so rounding to 3. Then at 2 comma 0, I have the pixels 3, 5 and 1 as the neighbors. So the output or the sum comes to 9 divided by 4, which is 2.2, I think, no, 2.5. So that's rounded to 3. Oh, sorry, not 2.5. 9 divided by 4 will come as 2.2, not 2.5. So this way, you're basically going to solve the entire list of the other pixels. So you should get something like, right, let me just check. Okay, so neighborhood averaging, you will get the output as this. Okay, just check if you're getting the same thing or if I have done any mistake. Okay, so then we have median filtering. Yeah, let me just get that image again. Okay. Okay. So in median filtering, since we have been specified that the median filtering window is 3 by 3. So now since we have median filtering and we also have to deal with the boundary pixels, you have to explicitly specify in your program how you're going to solve the boundary pixel issue. So since we cannot ignore the boundary pixel, we have to choose any of the other methods, that is either filling it up from the other value, that is copying the corner pixels into the window to fill the window up, or you can shrink the window. I prefer to shrink the window size, so I'm writing this as shrink median window for boundary pixel. Now you can use the other methods, that is copying the boundary pixel values in order to fill the window or filling the window with zeros. You cannot, however, use ignoring the boundary pixel. Okay. Now, in the first this thing, you basically have the values at 0, 0. You have the values as the if I were to place this particular window. Now, in this particular case, I will have to draw the window at this. So I will get something like this will be the window over here. The 3 by 3 window will come somewhere like this, wherein I have these other values, which will be here, 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 and here, which are falling outside the image. Okay, so what I'll have to do is I'll have to reduce the size of this window, since that is what process I'm going forward with. Okay, so when I shrink this window size, I will get this size as this much. Okay, where this 1, 2, 3, 4, and 5 values I do not have. So instead of the 3 by 3 window, I will be using a 2 by 2 window for the corner pixel, the absolute corner. Okay, so I'll be getting the list as 0, 2, 3, and 3 as my values, which I then have to write here in the sorted list. So 0, 2, 3, and 3. Just a minute, since this is a set, I prefer writing this as a list of numbers. So this way. Okay, so in this case, since I have an even number of values in my list, and if I have even number of values and I want to calculate its median, then I'll have to take the middle two values. So since there are 4 numbers over here, second and third value will be the median. So I have to take the average of these two medians. Okay, so the average of 2 and 3 will be 2.5, which when rounded to approximately 3. Then the next is this particular, that is 0, 1. So I'll be having this window shifted. Just a minute. I'll have this window shifted by 1 value to the right. I'll be having this line here. I'll be having it over here. So I'll be getting it something like this, wherein I don't have this, and these 3 values are going outside my image boundary. Okay, so here again I'll have to shrink the window. Instead of 3 by 3, I will have to use a 2 by 3 window. So I'm getting the values as 0, 3, 2, 3, and 2, 4. Okay, so after sorting, this will come as 0, 2, 2, 3, 3, and 4. So I have to write that as the list. So at 0, 1, I have to write 0, 2, 2, 3, 3, and 4. Let me just think. 0, 2, 2, 3, 3, and 4. Okay. So in this case, since I have even number of values, I will have to take the median as the third and fourth. The average of the third and fourth value will be the median. So the average of again 2 and 3, that is these two values, this and this. So that's 2.5 rounded to 3. Now, again, as I've said before, if you get something like this for 2 marks, you can just try to do this mentally, see what are the values at its neighbors, whichever are going outside, replace it with 0 and then get the values, or uh, try to do this way. But since this writing all of this is going to take a lot of time, and since you have only 2 marks for this, you just have to finally what is required is just the 4x4 matrix, that is the image. Okay, so here you had 3 and 3. So you are just expected to write the values as this list since it is only for 2 marks. If it was for 4 marks at least, then you can show all the steps. So here you would then get it as first one, these two were 3. Then at 0, 2, you would have 2, 2, 2 and 3, 4, 4. That is, since I have this particular pixel to be calculated, I'll have the values, the list of numbers as these 3 and these 3. So 2, 2, 2, 3, 4, 4. So I'll be getting the output, the list, sorted list as 2, 2, 2, 3, 3, 3. So again, the average of 2 and 3 will be my final median value. So that's also 3 and the output. So this will also come as 3. Then at 0, 3, I have the values 2, 2, 4, and 4 as the output, this as the sorted list. So here also average of 2 and 4, that is 3. Then at this particular pixel, that is 1, 0, you have 1, 2, 3 as the values, 4, 5, and 6 values. Since these 3 pixels over here, since the window, the median filtering window, once you place over here, you will get it something like this. These 3, and over here, this part is going to go outside. So you have 0, 2, 0, 2, 3, 3, 5, 5 as your sorted list. So the output is going to be average of 3 and 3, which is again 3. For 1, 1, you have 0, 2, 2, 3, 3, 4, 4, 5, 5 as the sorted list. That is, this is your central pixel. So you have 1, 2, 3, 4, 5, 6, 7, 8, and 9 values. In sorted order, you will get it as 0, 2, 2, 3, 3, 4, 4, 5, 5. So that means your median will come as 2, 3, 4, 5, which is 3. Okay, so here also your output is 3. Then at 1, 2, you will have 2, 2, 2, 3, 4, 4, 4, 4, 5. That is, since this is your central pixel, your window is occupying 1, 2, 3, 4, 5, 6, 7, 8, and 9 values. So your median, if you just try to count, since you have 9 values, your median will be the 5th value. So this is the first in the sorted list. This will be first, second, third, fourth, and 5th. Okay, then you can go 6th, 7th, 8th, and 9th. So this was your 5th, 4 was your 5th value. That is going to be your median. Then again, at 1, 3, you will have the sorted list as 2, 2, 4, 4, 4, 4. median will be average of 4 and 4, which will be 4. At 2 comma 0, you have the pixels sorted list as 1 1 3 3 5 5. So here you have your median as average between 3 and 3. So your output is 3. At 1 comma 2, 2 comma 1, that is this particular pixel, I have the list as 3, the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. So when I sort this, I'll get 1, 1, 3, 3. That is, this 3 is the fourth number. Fifth number will be 4. So my median over here will be 4. Then at 2 comma 2, I'll be having the list of numbers as this. That is 3, 4, 4, 4, 4, 5, 1, 6, 7. So when I sort this, this is going to be my first number. Then I have 3, which is the second number. 4 is going to be the third, 4 again as the fourth, and 4 again as the fifth number. So my median is again 4. Then at 2 comma 3, that is this particular pixel, I have the values as 4 4 4 4 6 7. So since this is 6 numbers, my median will be average of these two numbers, which is 4 and 4. So my median is 4. At 3 comma 0, I have the values 5 5 1 1 as the 4 values that will come. Since this is a corner pixel, I have only these 4 values. Okay, and since the median is going to be the average between 1 and 5, my average will come to 3. Then I have again then I have the numbers 5 5 4 1 1 6. So here I'll have the sorted list as 1 1 4 5 5 6, and since I'll have to take the median as average between the third and the fourth number, that's your average between 4 and 5, which is your 4.5. Since we are rounding it, we'll get the output as 5. Then we have over here as the calculation pixel, that is 3 comma 2. This will be 3 comma 2. So I have the pixels in the sorted list as 1 4 4 5 6 7. 6 number of pixels, so the median will be the third and the fourth value. So this is the first, second, third, and fourth, that is 4 and 5. So average in 4 and 5 will be 4.5 rounded to 5. Then I have this as the last pixel. So I have the values in the window as 4, 4, 6, and 7. And since I have to take the median between second and third value, my average will be of 4 and 6. So when I take the average of 4 and 6, that's going to be 5. So my final output after median filtering is going to be this. Sorry, black color. So when you are asked something like this with an image and the output that is expected, that is neighborhood averaging and median filtering, once you draw these two matrices, your 4 marks are done. Okay, 2 marks for each one. I think after this we had the PDF. Again, median filtering, neighborhood averaging, and contrast stretching. Now, contrast stretching, you will be given in terms of how many bits in that particular pixel are there. So over here, I have the maximum intensity value as 5. And if I were to plot, if I were to have pixel intensity as 5, the minimum number of bits required would be 3. Okay, so in a 3-bit image, then only minimum number of bits that are required would be the minimum size of each pixel would be 3 bits per pixel. So assuming that it is a 3-bit image, that is each pixel has 3 bits, we can apply contrast stretching to this with the linear transform. Uh, you would be having the equation. I didn't get my book. Does anyone remember what the equation for linear transform is? Contrast stretching, it's S into, no, the output is Vmax, sorry, f of x minus y is equal to, so the output g of x comma y is something in terms of f of x comma y minus b min divided by b max minus b min, and this is added or multiplied with the ratio. We're adding this with something. This I think comes on the right hand side of that plus f of x comma y minus b min. Okay, wait. I open the textbook. To raise to b minus 1. Okay, that was the only thing missing. That 2 raised to b minus 1 is actually the maximum gray level. So in this case, that would be 7, since we are having a 3-bit image. So our range is going to be 0 to 7, and we are asked to apply linear transform to this. So we would get something like, just a minute. Okay, so the image is 3, 3, 4, 4, 5, 5, 4, 4, 4, 4, 5, 5, 4, 4, 3, 3. Okay. So you have the gray levels 3, 4, and 5 in your image. So you just have to apply linear transform, contrast stretching using linear transform for these 3 gray levels. So after your application of contrast stretching, you should map 3 to gray level 0 and 5 to gray level 7. And you just have to calculate what will be the gray level for 4. So g of x comma y, you just have, actually don't need to use it as g of x comma y. You just need the main values, that is 3 would be mapped to 0, since we already know that b min is 0. So 3 minus b min is 3, b max is 5 minus 3, and this multiplied with 7. The numerator comes to 0, so rounding that to 0. Gray level 4 will map to 4 minus 3 divided by 5 minus 3 into 7. So that should come to about 1 divided by 2. That's half of 7. That's 3.5. So approximately 4. And the last one, that is 5, will map to 7, since that is 5 minus 3 divided by 5 minus 3 into 7. So that is going to come as 7. So the output image will look like something like this. I'll draw it over here. That is a 4 by 4. Will get, since 3 is mapping to 0, I will get 0, 0, and 0, 0. Gray level 4 is mapped to gray level 4. So level 4 is on the corners. So 4, 4, 4, 4, and these 4 pixels. And gray level 5 is mapped to 7. I have 7, 7, 7, 7. So your final image after contrast stretching will look something like this. Okay. And median filtering, 8 neighborhood averaging. Okay, 8 neighborhood averaging, you just have to take, instead of the 4 neighbors, you would have to take 8 neighbors. Do you want me to solve that with 8 neighbors? This particular question. Okay. Neighborhood averaging, contrast stretching, apply neighborhood averaging method. Okay, histogram equalization. What about histogram equalization? Should I solve this, or y'all have understood that concept? Okay. Neighborhood averaging, median filtering, contrast stretching, histogram equalization. Okay, question 8, we have this threshold filtering. Now, threshold filtering is just that if you are getting the average, now if you remember threshold filtering, the concept is that you are given the threshold value, and if this new value that you're calculating, if this difference between the current, the input image and this new calculated value is greater than the threshold, then you would have to take this new value only. If the difference between the newly calculated value and the original value of that pixel is less than the threshold, the difference is less than the threshold, then you would take the original value. Okay, I'll just explain this part. Just a minute. Okay, so you would basically have been given the image as 2, 5, 2, 2, 0, 1, 7, 1, 2, 1, 0, 2, 5, 3, 6, 2. Okay, and you're told to have threshold filtering where tau is equal to 4. Now, threshold filtering, this is the same as neighborhood averaging, but we just have to check whether the value, the difference between the two is greater than the threshold, which is given as tau is equal to 4. Now, at 0, 0, I will just quickly do this calculation. Okay. So I have the value at 0, comma 0, which is the average of 0 and 5. That is, since this is the pixel, I have to consider, let's just consider it as 4 neighborhood. Okay, so I have the average of 0 and 5. So that is going to come as 1. Okay, and the difference of the average, since it is the average is 1, and the new value that I've calculated is 1, and the original value is 2. If this difference is greater than the threshold tau, only then do I take the new value. Okay, now in this case, the difference is less than the threshold, that is, the difference comes to 1. So I take the original value over here. Then at 0, comma 1, I have the average of average as 2 plus 1 plus 2 divided by 4. So that comes to 5 divided by 4. That's 1 again. 1.2 it will come to. Okay, so average comes to 1. So 1 and the value is 5. And since the threshold is equal to 4 over here, I can directly take this as the same value as the original, which is 5. Now, in what you can do is you can either consider it as either the threshold is, I think, mentioned as less than, sorry, the value if it is greater than the threshold, not as greater than or equal to. I don't have my notebook in which I had specified that. Let me just recheck it over here, whether it is less than or less than equal to. Sometimes it's smoothing, neighborhood averaging should be next. Threshold averaging. Greater than. If the absolute value difference is greater than, then only you consider it as the new value. Otherwise, you consider it as the original value. So in this case also, we can't take the newly calculated value. At at 0, comma 2, you would basically have the average of 5, 7, and 2. So that's 14 divided by 4. So 14 divided by 4 will come to 3.5. So average of 4 minus 2, that is again not greater than the threshold. So again, the original value. Then this at 0, comma 3, the new value will come as 3 divided by 4, which will come as 1. So again, that less than the threshold. The difference is less than the threshold. Here at 1, comma 0, it will be 5 divided by 4. That's 1. Again, less than the threshold. This value will come to 13 divided by 4. So that's 3.2. So 3.2 difference isn't greater than the threshold. At this value of 7, you will basically get it as 2, 3, 4, 4 divided by 4, which is 1. Now, in this point, you are having the first time your average as the sum comes to 4. That is, since this is my pixel whose value I want to calculate, the sum of 1, 0, 1, and 2, these 4 numbers, comes to as the sum of these numbers comes to 4. Average will be 1. So since 1 minus 7, the absolute value of this, is greater than 4, that is the threshold, I have to set the new value, which is 1. I think the rest of the values you won't be getting any difference. Let's still check. 2 plus 2 plus 7, that's 13, 13, 11. 11 divided by 4, that should come to about 3. So difference is again less than the threshold. Here you would get the output as 6 divided by 4, that's 1.5, so 2. So that's the same value. This point will be 6 divided by 4, again the same value. 0, you'd have 7, 14, to 16. That's 4. Now, at this point, you are having a 0 and 4 as the values. Since this is not greater than the threshold, we will still have the original value as 0. This will come to 3 divided by 4, approximately 1. That's still 2. And average of 2 and 3, that's 5. So 1. So difference comes to 4. So again, the original value. 5, 1, and 6, that's 12. 12 divided by 4, that's 3. It's again the same value. And 3 plus 2, 5. 5 divided by 4 is again 1.2. So here, another one. Difference here will come as 6 minus 1. So this average of this particular pixel, at this pixel, you have the sum of 3 and 2, which is 5. 5 divided by 4 will give you about 1.2. And so rounding it up to 1, you'll basically have this as 1 minus the original value, which is 6. So the absolute value is greater than the threshold. So you will take the new value that you're calculating as 1. So you're basically changing only 2 pixels in our threshold averaging in this case. Okay, so here you will then have the average of 6 plus 2, which is 8 divided by 4, which is 2. So after neighborhood averaging, you will basically get this value. Is this understood? Okay. One thing I want all of you all to see is this particular one. Okay. If you all remember, I told you all that you all had one of the question papers had this particular numerical, wherein you are basically given the transform, that is what will be the output of your pixels given a particular image. And you're given the input as well as the output pixels, and the transform function is this. So given this particular image and you're told to apply the given transform to get image Y, and then apply median filtering to Y and specify the pixel intensities. So this particular image is given as image X, and to this image you have to apply this transform. Now the transform is such that whatever is the input, that stays the same unless you are in the range of 70 to 80. Inside 70 to 80, you have the value set as 200. Okay, so any pixel value between 70 and 180, all of those values will be set to 200. The rest of the values are staying the same as the input. Okay, so given this particular image, let me just take the picture of this, because then let us switch to the other window. I don't know why exactly, but the smartboard doesn't support extending the window. Otherwise, it would have been much easier. Okay, anyways, so given the image as 55, 75, 90, 100, 120, 60, 90, 190, that looks like 180, 190, 175, 175, 140, 100, 100, 56, and 210. Okay, and the transform function is given as having anything between 70 and 180 is set as 200. Okay, so you'll be having anything as 70 and 180. Just draw the transform function here. you will actually have a straight line, and in between 70 and 180. If this is 70, this is 180. So approximately at the spot, approximately here, we are basically wiping this part off, and this is set as 200. Okay, this value is set as 200. So any pixel over here in this image within the range of 70 to 180, so that will be set as 200. So we have the pixels as 70 to 180. That is this one, this, 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 this. Okay. So all these pixels which have been marked, all those pixels have to be set as value 200. The rest of the pixels, since they're outside the range, they will stay the same. So you would get the final output as 55, 200, 200, 200, 200, 60, 200, 190, 190, 200, 200, 200, 100, 200, 56. Was that 56 or 50? Just check. 56 and 210. So your final image as the output will basically look as this. So you would get the Y image as this part. And I think the second part is applying median filtering. So you would then apply median filtering to this image. Okay. What we'll do is, if you're having any difficulties with the numericals which are there, just let me know exactly which numericals you all want me to solve in class. I'll try to solve at least one numerical in class. Okay, and during Tuesday's lecture. Okay. Otherwise, we will proceed with the next topic, which is geometric this thing. But we have to also finish those derivations that for constrained and unconstrained conditional restorations. They will actually 30 minutes will be enough for that particular derivations. So if there are any numericals you feel difficult or you haven't understood, just let me know during Tuesday's lecture. Okay, we'll solve some numericals on that. Okay, any other questions y'all have for today's? IT2, you may get one derivation. Either the conditional, unconditional restorations, inverse filtering, Wiener filtering, one of these you may get one, and maybe even Laplacian. When exactly IT2 is, that I do not know. Roughly, it should be in the last week or of November or the first week of December. That is like the tentative date. It's not as fixed that I know of, but you will be having IT2 as the syllabus for, sorry, Unit 2 as the syllabus for IT2. Okay, question bank, I will upload. Didn't I upload the entire thing? Okay, I only uploaded for Unit 1. Okay, I'll upload the question bank for Unit 2 and the rest of them also. Okay. Uh, but in case you're having any difficulties with the numerical, just let me know during the physical classes, because then it becomes much easier compared to teaching it online. Okay. That's it for today. Y'all can leave. Thank you.